Okay, this is the final question of this exam, question number 4, and it is in 3 parts related to logic mostly. So in part A, we are given a statement, in broad language. So we are going to convert it or express it in first order logic. So the statement is all citizens of Turkey and non-citizens with valid visas are allowed through border control unless they have an arrest warrant. So to be able to express this in first order logic, we need to define our predicate functions. So let's see what we need. Now, citizens of Turkey, so we need something to denote that. Let's say T of X is X is a citizen of Turkey, okay? And non-citizens, well, it will be the negation of this with valid visas, okay? So let's say V of X is a holder of a valid visa for Turkey, let's say. Okay. Allowed through border control, that's another thing. So let's say B of X is allowed through border control. They have an arrest warrant. So WX, X has an arrest warrant to their name. Okay. When we define these, now we are ready to express the given statement. So this and this people are allowed through border control. So this is the main thing. So if you satisfy this or this or this, then you will be allowed. So this is sort of an implication. Therefore, I'm going to write for all X, something will allow you to be allowed to border control. So something will imply B of X. And that something, what is that something? Well, number one, all citizens of Turkey. If you are a citizen, you are allowed. So T of X. And non-citizens with valid visas. So that's T of X. So I'm going to put as a parenthesis here. T of X. Or, so I'm going to move this bit here. Or you are not a citizen, but you are a visa holder, so V of X. Okay. Unless they have an arrest warrant. So this will allow you unless you are not being pursued. Okay, so this or this, and you shouldn't have an arrest warrant, so not W of X. Okay, together, another set of parentheses here will let you through the border. So this is the answer. Okay, moving on to part B. Here we have an argument in propositional logic, and we need to use resolution to determine the validity. Okay, so remember, for resolution, there are two things we need to do. First, you need to negate the conclusion and put that among other premises and put everything in clause form. So this will be P XOR S, R implies S, P or R, and negate this and take as another premise. And after I apply resolution, what I'm looking for is an empty clause. If I can reach to the empty clause, I will say that this is a valid argument. And to be able to do that, I need to put everything in closed form. And remember what closed form is. Either you will have literals by themselves, or you need literals combined with ORs. So XOR, I need to get rid of the XOR and to put it into closed form. So remember what XOR is. P and S shouldn't be the same, shouldn't have the same truth value. So either one is true, the other is false, or one is false, the other is true. So how do you express that in closed form? That will be P or S and not P or not S. Okay, so this is equivalent to P XOR S. And remember, when you have this AND here, we have to break this into two clauses because these are going to be the premises anyway. So all the premises are combined with ANDs. Therefore, I will just get rid of this and put the second thing here as a second premise. So I can also get rid of the parentheses. So the XOR is done. Next, I have this implication, and that's equivalent to not R or S. Okay. And this one is already in closed form, P or R. And finally, the negation of P XOR R. So similarly, this will be expressed as P or R and not P or not R. And if you negate this, this will be P or not R and not P or R. And I will get rid of this and make the two into two separate clauses. This will be P or not R, not P or R. Okay. Now at this point, everything is in closed form and I'm looking for the empty clause. Remember, you cannot do, okay, I have here S and not S, P and not P. I can resolve everything to get the empty clause. This doesn't work. One literal at a time. Don't forget that. This doesn't work. So, for instance, I can use R and not R in these two to obtain P or S. Well, I already have that, so that doesn't help. So let's look at others. What about this? I have not S in one and S in the other, so this will give me not P or not R. Okay, and together with this, resolving over P and not P, we would have not R or simply not R. Okay, does this help me? Okay, let's see. Along with this, should I do that? Or maybe I can try this one along with this. I have P or R and I also have not R. Resolving over R, you get just P. And then resolving these two, I have P here and I have not P here. So this together will resolve into R. And these two will resolve into the empty clause, which means the argument is valid. Remember, there is not a unique way to do this. As long as you can reach the empty clause, that's acceptable. And you can use clauses multiple times. What you need to be careful about is you cannot resolve multiple literals at a time. So just one literal at a time. Careful about that. Okay, so that's the end of part B. In part C, again, we want to do resolution, but now the statements we have are in first order logic. So we need to do some extra steps here. And first, we need to get rid of the quantifiers. And even before that, you can negate the conclusion and accept it as a new premise. So negate this. There exists X, there exists Y, QXY, or S of X. Now, this will become for all X, for all Y, negation of this entire thing. And that will be by De Morgan's law, Qxy, and, well, this will be negated, and negated S of X. Okay, so my premises are going to be including this final statement. Now, I will get rid of the quantifiers. And remember, if you have a universal quantifier, just get rid of it. And if you have an existential quantifier, introduce a column variable, or rather a column constant. So here, I have a for all x here, so that will just go. And I will be left with there exists a y, Q of x implies Q of xy. Now, instead of this y, due to the existential quantifier, I will just introduce a column constant. So this first premise will be P of x implies P of x. Instead of y, I'm going to put column very constant 1. And the second premise here, again, I have an existential quantifier. Therefore, I'm going to replace all s's here, all x's here with a column constant. And that will be different than the one I used for the first premise. And that will be s of, instead of x, s of s2 or p of s2. Okay. And finally, I should have this as my third premise. And since I have universal quantifiers, I just get rid of them. And therefore, I will have not Q xy and not S of x. The only thing left to do is arrange these into closed form. Now, I have the implication here. The implication I can rewrite as not P of x or Q of x S1. The second premise is already in closed form, so that is S of S2 or P of S2. And the third one, you see I have an and here, and therefore I have to break it into two separate clauses. And this will be negation of Q xy, and then I will have negation of S of x. Now I have 4 premises, and I'm ready to resolve them. Again, I'm looking for the empty clause, but I have to be careful about the unifications here. So what can I do? Let's see. So I have S here, and I have not S here, and therefore I can use that. So these two will resolve, but I need to use a unification here because S here has as a parameter a column constant, and S here has a variable. So I'm going to make a unification here, x into S2, and I'm going to have P of S2. Okay. Then I can use these two because in one I have P of x negated. Here I have P of S2. Again, I'm going to make a unification here with this replacement. And what I will be left with is, remember, I have an x here, therefore S2 will appear in Q, S2, S1. And finally, this one and this one will resolve with x into S2 and this y here into S1. And I will just be left with the empty clause, and therefore this argument is also valid.